Hi, everybody. We are on to session 21 in the CSEC Quadratics course. And actually, to be honest with you, we are only a few sessions, probably one, maybe two sessions away from finishing the CSEC maths part of this syllabus. So if there are anybody else from any other countries watching this here, not in the Caribbean, CSEC stands for um, Caribbean Secondary Examinations Council, and that is our branch of the Caribbean uses one examining body, and they create the main exams for us for matriculation to higher levels. And this is just the mathematics section for quadratics of this examining body, and I just covered this here, but it is useful to anybody around the world who wants to explore quadratics, right? So using vertex form to sketch a quadratic curve, we almost finished. We're pretty much down to the end of quadratics here, right? So let's use this now. So using vertex form. So if you're not sure what vertex form is, please go back to the last video. Don't stress yourself out here if you're now looking at vertex form. Come to this video afterwards. Go back to the last three videos and we dealt with vertex form there. Maybe four videos, I believe. So, vertex form, we learned this is vertex form here, the vertex form of a quadratic. The vertex form of a quadratic is y is equal to a into x plus h squared plus k. Now, last class, I forget to put this in here, but I mean, we noticed it, but I didn't write it in, and we should, right? Where a, h, and k are constants. Now, again, what is a constant? A constant is a number that you know. X is any variable. X is any variable, right? And lastly, now, a cannot be equal to 0. Now, we know the reason for this from before when we did quadratics in the earlies. You can jump straight back to the early first or second sessions and you'll see what it is. Or maybe actually the third session when we started quadratics. So let's see now how we are going to use this form to sketch a quadratic curve. So let's say we are given this here now. So if we consider the form. Y is equal to a into x plus h squared plus k. Now, when we did the graphs in, let's see which one that was. Um, Session number 13, 14, session 13 and 14, right? We would have talked about the quadratic curve, right? In that curve, you saw the important points there. You saw what was the important points that you needed to get off of a graph, right? So from this here, how do we get all of those things, right? If you drop back to that, you will see it there, right? In session 13 and 14. So the first thing we needed to see was the nature of the vertex. So if you forgot what the nature of the vertex was, it is whether it is a minimum point or a maximum, whether the graph looks like this or whether it looks like this, right? This is a minimum point graph, a maximum point graph, right? How do we find the nature? And this is very easy. If E is greater than 0, if A is greater than 0, right? That means if A is positive, right? So if A is a positive number, then the graph is a minimum point. Then the graph is a minimum point graph. The graph looks something like this. Yeah. Similarly, if E is less than 0, if E is less than 0, right, and any number less than 0 is negative. So if E is negative, then the graph is a maximum point graph. So if this number that in brackets is being multiplied by is positive, the graph is a minimum point. If the number is negative, it is a maximum point, right? A number which is not negative or positive is 0, but remember, A can't be 0. Yeah? So that's your first one. The second one now. How do we find the coordinates of the vertex? Coordinates of the vertex. And this one is very easy, right? It's a nice simple formula. Now, this is why we call this vertex form. Because one, you can determine the nature of the vertex from this by looking at A, and the coordinates of the vertex come straight from this as well. In this form, the coordinates of the vertex are just minus h key. Now, what does this mean? I will show you an example on this afterwards when I finish explaining everything. But basically, whatever h is, if h is positive, this means make it negative. If h is negative, this means make it positive. But in this case, k is whatever k is. So if k is negative, it stays negative. If k is positive, it stays positive. So this is the formula for the coordinates of the vertex. The third one is for the roots. Now, how do we get the roots here? Now, if we remember what the roots were these values here, and here. Remember, these roots occur where y is 0, right? Remember, this is on the x-axis, so the roots occur where y is 0. So the roots occur at y is equal to 0. And the roots are x values. So how do we find the x values when y is 0? Sorry. Right, my screen just scrolled across there. Right, good. Yeah, so how do we find these values now? Very, very, very easy. Nothing too bad. So our steps for this here are step 1, right? Let y be equal to 0 in this equation. And step 2, well, step B, sorry, in this case, step B is solve for x. Now, this is easier said than done, but we will get to that in a little bit on how we doing it. Step 4 now, how do we find the y-intercept? Right? So, where's the y-intercept of any graph? The y-intercept of any graph is where the graph cuts the y-axis. This is your y-intercept here. But remember, on the y-axis, x is 0. So the y-intercept occurs, because on the quadratic graph only cuts the y-axis once, occurs at x is equal to 0. So just like previously, E, you let x be equal to 0, and part B, solve for y. Right? And look at how much information you're getting from vertex form. It is so useful. You could use this to sketch your entire graph. Now, there are other ways to find these things, but if you're getting them all in one, it is very, very, very easy, right? Next one now. Step 5. Right, so we want to get now the next thing that I taught you all about is the axis of symmetry. So let me think about this one here, right? The axis of symmetry is the symmetrical line that cuts the graph in half, of course, right? Now think about where this passes through. And this passes through the minimum point or the maximum point. But and the coordinates of this is minus hk. So the axis of symmetry is quite easily x is equal to minus h. So whatever h is, you change the sign in front of it. If h is positive, make it negative. If h is negative, make it positive. And then the axis of symmetry is quite simply the equation x is equal to h. And last one, this is one that we didn't do before. This is what we call the minimum or, right, minimum or maximum value, a maximum value of the function. Right now, in this case, the function is just a fancy way of saying y. Right, so just keep that in mind. This is the minimum value or the maximum value of the y function, right? So the minimum or maximum y value occurs here at the vertex. Yeah. So quite simply, the minimum or maximum value of the function is just y is equal to k. Yeah, whatever k is, that is the minimum or maximum value. And this is how we use the quadratic curve how we use the vertex form to sketch our curve, how we get all of these important things off of the vertex form, right? So this is very, very important. This is how we do how we use vertex form in these questions, right? So with that being said, I will end off the video there because to do a question for this particular topic is pretty long, right? So I will have another video, at least one more, if not two videos, because it will take me around at least 6 or 7 minutes properly to do one question, right? So I want to do at least two of these questions with you all to show you how to use these things here. But these six conditions are words to live by for your quadratic sketches. All right, so with that being said, that is it for this session on session 21. And I will see you all in session 22, where it is we'll be doing some examples of this. So until then, everyone, take care and stay safe.